Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data migrations are brutal. They drag on for months, sometimes years, burning through resources and crushing team morale. Datafold's AI-powered migration agent changes all that. Their unique combination of AI code translation and automated data validation has helped companies complete migrations up to 10 times faster than manual approaches. And they're so confident in their solution, they'll actually guarantee your timeline in writing. Ready to turn your year-long migration into weeks? Visit dataengineeringpodcast.com/datafolds today for the details. Your host is Tobias Macy, and today I'm interviewing Derek Collison about NATS, a multi-paradigm connectivity layer for distributed applications. So, Derek, can you start by introducing yourself?
Hi, thanks for having me, Tobias. I'm Derek Collison, known mostly these days as the creator of NATS, but founder and CEO of Synadia. But in prior lives, I spent some time at Google and VMware writing a system called Cloud Foundry, and way back in the 90s at a company called TIBCO. For those that were in Wall Street or the world's financial systems, TIBCO was kind of a heavy hitter back in the day.
And do you remember how you first got started working in data?
It wasn't necessarily data per se, but when I graduated university, I went to work for a group called the Applied Physics Labs of Johns Hopkins University. And so instead of the introduction to data, it was the introduction to distributed systems. But I'll tell you that I felt kind of penalized because I got selected by the second best physicist at the lab. And so they had not as much supercomputer time, right? And for the audience, the used to either scale vertically or horizontally wasn't really even a thing back in the late 80s, early 90s. And I remember the physicist saying, well, why can't you make those 12 Spark pizza boxes in the basement do the same thing as like a Cray supercomputer or a connection machine? And I thought that I was in the penalty box. But shortly after leaving that job to move to California, I got thrown right into the same thing. And it was kind of very lucky by chance that I did, because now everything's a horizontally scalable distributed system, right, these days. But at the time, I just kept saying, why am I getting penalized? Why do I have to keep doing this type stuff? And so this was mostly around moving data and access to data. And so a lot of the systems that I designed, even through the early days at TIPCO, were mostly moving things around. It wasn't really until kind of RVCM, certified messaging, which most people won't even remember. But after that, I designed a system called TIPCO ZMS, which was kind of like Kafka is today, right? The big player at the time in the space of storing messages and being able to replay them through consumer patterns was probably IBM's MQ. And so we went down the path with Sun and IBM and others around a standard called JMS and Sun, obviously. And then TIPCO ZMS was, JMS compatible. But the big step change there was is that we would store and hold on to data, not just move it through pipes, so to speak.
That's definitely a lot of useful history and context for a product like NATS and what you're trying to solve there. I imagine that you also had a lot of lessons learned in the process of building and working on Cloud Foundry, because to my understanding, that team was also very closely linked with the team that was responsible for RabbitMQ, which was a very popular queuing system and still is for the publish subscribe message pattern. And I'm wondering if you can just describe a little bit about what it is that NATS is and some of the core problems that you're aiming to solve with it.
Yeah, so originally NATS came into existence as part of Cloud Foundry, my work at VMware designing that system. And, we didn't want Cloud Foundry to kind of just be an enterprise pass, but that's how I pitched it to the senior leadership, Paul Moritz and Steve Parrott and Todd Nielsen at the time, that it was like a Heroku for the enterprise. But we couldn't just have like Java apps and Spring apps and MySQL. And so we wanted to do some cool things. And so we brought things in like MongoDB and Node, but at the same time, we also brought in Redis. And we also needed a messaging system simply because that's how I designed systems, right? I was used to designing over top of messaging systems. And at the time, the only one out there was RabbitMQ. So we, had VMware also form a relationship and actually purchase the consulting group that was in charge of RabbitMQ. And a lot of people probably know Alexis, who was kind of running that at the time. But what's interesting from a pattern perspective is that I think RabbitMQ was designed around the AMQP protocol, which I know sounds very familiar to a lot of your your audience, but in some ways, our time at TIPCO indirectly resulted in the AMQP spec, right? The financial markets and technologies were trying to make sure that they didn't feel vendor lock-in with TIPCO at the time, and TIPCO Rendezvous, which I helped co-design and things like that, and then of course TIPCO's EMS. But what Rabbit would do is if you asked it to do something, it would try to do its best to do what you asked it to do. And that on its surface sounds really, really good, right? Sounds like something that you would want to have happen in a system. However, imagine if the metaphor is like I could plug in my crazy blender that I designed on my 3D printing machine and blow the whole neighborhood's electrical power out, right? People would kind of look at me like, no, I mean, it'll trip a breaker, it'll throw a GFI, there's ways to protect that. And what I was really looking for was kind of a dial tone, a system that no matter what was being asked of it, it would protect itself at all costs. And believe it or not, I know it sounds very subtle, but there's a profound difference in the way NATS came to life around that principle and a couple of key features that I needed that Rabbit simply didn't. And so we made a decision at the end to utilize NATS for telemetry, command and control, and querying of a Cloud Foundry, the Cloud Foundry components, which in the early designs were pretty simple. It was a cloud controller and a bunch of DEAs, which is an interesting way to say engineers should not name things, right? It was, I think, 2 a.m. and me and Vadim Spivak, who came over with Mark Lakowski and I to VMware from Google, we were sitting around 2 a.m. and like, what are we going to call this thing? It's like, oh, well, it's cloud. There's droplets in clouds. We'll call it a droplet execution agent. So it was called DEA. And so that's how NATS was born. So again, it was protect itself at all costs, be like a digital dial tone, or be like the electrical grid, meaning it's always on for everybody, but one bad actor can't take the whole system down and be destructive for everyone else. And there was a couple other patterns that RabbitMQ did not do that I really wanted, which most people in the modern NATS ecosystem don't take advantage of. But one of the ones was I want to ask a unknown set size a question, and I only want the first answer. And you can imagine a world where if the messaging system is pretty fast, and let's say there's 10,000 or 100,000 of these things, that the client that asked the question gets the first answer, but has to throw away 99,999 other answers, right? So there's a CPU spike, and of course there's network costs and things like that. And so the original NATS had protect yourself at all costs as part of its DNA, do the normal things, pub sub, which for those that kind of think pub sub is outdated, and I would agree with you. Don't think of it as publish subscribe. Think of it as location independent addressing, whereas like IPs and DNS, for the most part, are location dependent. And if they're not, they're doing unnatural acts to get around that, Anycast or DNS tricks or whatever, load balancers, GSLBs. It had the circuit breaker pattern that I talked about, which is I'm going to ask a question, I only want the first answer, and I want the system to circuit break all the way through the system, regardless of how many components are in there, so that me as the actual client, I might get like 3 responses, and I only really want one, but the client only has to drop, let's say, 2 extras or something like that. And then the last one was distributed queuing, meaning not queue in terms of store something on disk and replay it, which came later in the NATS evolution. But from a simplistic standpoint, it's I can have any number of entities listening, let's say on foo, but they all join a certain group, let's say bar. And what it's telling the system is that when a message comes in on foo, only deliver to one of the bar recipients, right? And so this is not necessarily brand new. It exists in other systems, but the fact that it was totally dynamic, meaning you didn't have to change any configuration of the NAT servers or NATS components or anything. It just kind of worked from an application perspective. And you could create, hundreds of thousands or millions of these all over the place. That was a really good one. And for those in the audience, right, this is our version of batteries included, where you don't need load balancers and GSLBs and things like that. And so that's how kind of NATS came to fruition. We originally thought and pushed pretty hard that Cloud Foundry would be the first open source project that VMware did. And that was a big step change for the company. To coincide with that, I released the original NATS project as MIT. I think it still powers, most of the telemetry and command and control and queryability of Cloud Foundry systems, as far as I know. I'm not totally sure, but I think it does.
And in messaging and distributed data systems, there have been a vast number of different protocols, patterns, implementations of those different core capabilities from the perspective of lightweight, distributed, easy to interoperate with. Another system that comes to mind is ZeroMQ, which doesn't have that centralized command and control capability as much as it is just you implement it and build whatever pattern you want and it's application dependent there. But you also alluded to Kafka, which has taken the data ecosystem by storm from its inception, and there have been numerous other versions of that and implementations to target that same interface for being able to be compatible with the broad ecosystem that has grown up around it, but address some of the operational shortcomings that were inherent to its initial design. And I'm just curious, from your first implementation of NATS and as the evolution of messaging systems and use cases that they're powering have gone on through a few different generational shifts, what are some of the other sources of inspiration that you've drawn on to understand where to bring NATS from a feature perspective, but also any of the ecosystem investment around it that has been core to maintaining its viability and appeal to a broad audience?
Yeah, I mean, that's a great question. I think the next big piece in the NATS ecosystem that we really bet on was is that, and it was the first kind of tagline that Synadia had, which was connect everything. And what that meant for us is that the servers couldn't look like these massive brokers that were in perimeter security models and could only run in big machines on, in the cloud or in a data center or whatever. It was literally that we had multiple ways to connect servers together into pretty much any topology you could imagine that could stretch between any region, any cloud provider, or multiple cloud providers, which is a pretty common one for our customers in Europe these days, out to the edge. And when we were looking at the evolution of NATS in this way, we felt that whatever edge was, and we kind of defined it on our own as near, far, and beyond. Near edge is cloud providers saying we can do that too. A little bit of FOMO, and from my perspective, cloud is not going away anytime soon. So don't misinterpret what I'm about to say. But I think cloud is already the new mainframe. People just don't know it yet. When you interact with technologies and you say, "Oh, I'm interacting with the cloud," I can probably tell you that 90% of the time you're not. Right, you're operating with CDNs or more specialized edge providers, and that's kind of the far classification is the Akamai's and Fastly's and some of the newer entries in there like Netlify and Dino Deploy and Vercel, of course. But where it became really interesting is what happens if edge is what I define an edge as. It's my web browser, it's my phone, it's my factory, my distribution center, it's my cellular tower, it's my electric vehicle, right? Then the rules become very different. And I really do believe that when we went about making, these servers more like cattle than pets, if you remember that thing, we also really worked hard on how you can glue these things together to form a topology across any of those deployment infrastructures. So that was kind of the big next step. And then to the meat of what you were asking about was, and we knew this from our time at TIPCO, which is we eventually have to store messages. But in our opinion, that had to be a complement of the at most once delivery mechanism. So 0MQ is mostly at most once. I mean, and of course, Kafka is at least once or exactly once. And so what happens is that if you're in a Kafka ecosystem, and we've seen this through some of our customers where they say, "Oh, we wanted to use it for microservices, but we're storing everything on disk, the requests and the responses, and it's just too slow." It's kind of like asking Google to do all of their logging and processing before they give you Google search results. I don't think you would get anyone inside of Google that would look at you and think that's a good idea. Similarly with AMQP and NATS as it originally existed, eventually you need to persist data, right? And for the evolution within the NATS ecosystem, that was a technology called Jetstream. Now we did do an experiment with something called Stand, which was very interesting because we wanted to dip our toe in the water and see, if people were really, wanting this functionality. And the clear answer was yes. And so Jetstream now allows us to do both at least once and at most, or at least once and exactly once processing, but NATS core still exists. So if you want to do high speed global microservices where all you're trying to do, and by the way, when people ask me what Synadia does, and it's a very short elevator ride, I say, we're a technology stack that allows you to dynamically and securely reduce latency to access services and data from anywhere. I mean, that's really all we're really, really doing. And so you can imagine you're trying to vertically scale or horizontally scale, right? A problem, but if the problem exists all the way on the other side of the world, right? And you're tromboning back and forth, let's say, I'm on the East Coast of the United States, tromboning to, let's say, Japan, you feel that that's an experience that you're going to detect that latency. And You still can't break the speed of light. And so that topology, and then of course the data piece with Jetstream were the two big things that we kind of started Synadia, a little over 7 years ago
There's
around.
so many different directions I would love to take this conversation, but given the audience that we're addressing, I think another very pertinent topic to explore, given the core technology and the availability of a persistence layer, is the idea of what has typically been a fairly clean divide between application and operational systems. This is something transactional, I need high throughput, and your data systems, which are typically batch oriented. Obviously, there has been the introduction of stream processing, etc. There's also the trend of doing user facing analytics, but those are typically still powered by different systems than your application stack. And the default mode of thinking about these is that you store all of your transactional data and then you copy it somewhere else, and then you do some other stuff with it, and maybe it makes a round trip eventually. Core to that is the idea that the technologies powering those stacks are largely disparate. They're focused on different scalability patterns, different access patterns. Kafka is one of those technologies that changed the thinking a bit, but I'm wondering, because of the fact that NATS does support both that AMQP style or Redis queue style, I just need to push something and get something, I need fast messaging, as well as I can persist this data and replay it over and over, how that changes the ways that teams think about their overall architecture going from application through to data systems, and maybe some of the ways that they can reduce that unnecessary copying.
Yeah, I mean, the way we approached the problem was we definitely felt that inside of NATS, we call, something that collects messages a stream, right? The low level concept, way underneath the covers. That a stream with a bunch of messages that you can, replay at will, you can do all kinds of interesting things in terms of consumption models and at very high speeds would definitely still be applicable. But we felt that there should be something in between until you go to something like Kinesis, which abstracts out the semantics of what's in the stream. And so when we designed Jetstream, we said, you're going to be able to store messages. Obviously, you're going to be able to synchronously replicate them for HA. You're going to be able to asynchronously replicate them in multiple different patterns for like digital twins. We call them mirrors, or source mux and demux, which are really good for like IoT or fleet types of design patterns. But what we also felt we wanted to do was build materialized views. And so we've only built two, but they're fairly powerful. One's a key value store. And so you can treat Jetstream as a construct as just a key value. And because it's built on NATS, which, underneath the covers is powering a lot of the functionality, things that may or may not be difficult in other systems were trivial for us to do, which is you could have a history as long as you want it. You can say, oh, I want 100 of these values. So every time you update foo, keep, the last 100 values. And more importantly, the notion of an async push-based watcher, or pull-based, but push-based, meaning I don't want to keep polling for something. Just tell me anytime Tobias changes this key or someone changes this key. And the key can be changed from anywhere in the world. The key could be living, somewhere, let's say in Asia, Pacific region, but there's digital twins in North America and Europe, and I'm in North America, and I just want to be notified whenever that key changes. So for us, that was very trivial to do. Now, we didn't think, and by the way, Salvatore, for those online, Antares, right, the guy who's coming back to Redis, but, was the original creator of Redis, is a friend of mine, and we worked closely together when we had Redis as a component of Cloud Foundry and sponsored a lot of the early work and brought Salvatore over to the States and stuff. We did not think that anyone would ditch Redis for what we were doing because we looked more like Memcache, right? The values were an opaque blob, XYZ. But we were very wrong. And what we found out very quickly is that people do value the functionality of Redis a lot, especially the value semantics, meaning the value can have a shape, right? It can be a counter, it can be a list, it could be a map, those kind of things. But in critical production scenarios, clustering and stable storage trump it, right? And so these early customers said, we really want you to go into value semantics, but we're going to switch now anyway, because we need to be able to depend and have flexibility in the clustering, the way the system could cluster together across different deployment models. And then also the notion of stable storage, being a first-class citizen. And so we are leaning into value semantics for key values, but key value is a really, really big pattern for us. global microservices without having to have all the load balancers and service meshes and API gateways and 15 million different things going on there. Those are really two big key areas where people look at what NATS provides as a potential central nervous system. And the sole purpose is to be able to securely access services and data from anywhere at low latency, as we discussed earlier.
Another interesting aspect of what you're building is that it seems that it can potentially replace whole categories of technical systems, albeit with different operational characteristics or different guarantees, but it can also be very complementary to those same systems. So again, I'm thinking in terms of Kafka, Pulsar, etc. You mentioned Redis. You also mentioned service meshes. And I'm wondering for teams who, especially, have already done a substantial investment in their operational capabilities, they've built their application stack, they've built their data systems, and then they come across a particular problem that doesn't quite fit the patterns that they have addressed, that doesn't quite fit their technology stack. They turn to NATS and say, oh, hey, this actually solves my problem perfectly. What do you see as the progression of the rest of their technology stack once they bring NATS into their
Yeah.
operational characteristics?
Yeah, and so it depends on almost the breadth of the investment from a scope and an operational aspect. So what I mean by that is we do see lots of situations where folks are trying to get data on the edge into the cloud, into Kafka. And the first thing that people might consider is, oh, we can run a Kafka broker on the edge, and then we can use Mirror Maker or some other technology, right, to kind of do that. And a lot of, at least Synadia's customers, found that extremely unwieldy. And so they said NATS doesn't need any special security stuff to be secure. So it doesn't need a perimeter security model. It's not Java based. So it's, the binary is a lot smaller versus, and it's a single binary versus setting up something like Kafka. Now, I don't think Kafka requires Zookeeper anymore going forward, but it used to. And so we would see a lot of customers saying, we want our applications to talk to NAT/Jetstream at the edge and store it locally. And then NAT is responsible for getting it to the cloud, right? So that the application doesn't have to kind of worry about that. Now, of course, if you have really clean pipes to the cloud or you're running in the cloud, right, your edge is actually, that near category that we were talking about, that might not be as big of a problem. But when you're going across cell links or satellite links or combination of multiples of those, right, depending on which one's working better, what they really wanted was this separation of the applications running at the edge, not having to be bothered with, I generated the data, you just take it, you're responsible for getting it to the cloud. Don't make me responsible for that. So with Kafka, we've seen a lot of complementary things where we will run at the edge and they're still running massive Kafka clusters, or a cluster within the cloud. In microservices, we see, a slow sea change when they kind of drink the Kool-Aid and they go, oh, wow, we don't need all these, extra moving parts. We'll see slowly migrating across there, but it usually replaces, or at least customers indicate that they're going to replace everything. And some customers indicate they're going to replace Kafka too, once they get comfortable with the technology and they go, well, why are we, spending this much money and all these people to babysit this massive Kafka cluster when we think Nadius Tech, the NAT stuff could do it. The other one though that's interesting is like with KVs, most of them, if they talk to us, they'll leave Redis around, but again, they will signal that, hey, eventually we'd rather just run this. And I do believe, at least for the audience, my career started in the 80s, so I'm getting up there. But what it has given me is an interesting perspective that the technology landscape goes through these massive waves. And one wave is on the way up, which is I want more tools in the toolbox. And then we reach an apex and then we go, holy smokes, we want to simplify. We don't want all these moving parts. We want to, and what's interesting is right now we're in a massive simplification down spiral, right? And so customers that come to Synadia a lot of times are in pain. They can't seem to solve a problem, usually out at the edge. But once they've solved it and they realize that the system can take on a lot of different functionalities, it helps them in that mindset of, hey, we're trying to simplify, reduce costs, things
To
like
the
that.
point of when you're running far on the edge on a mobile device, an electric car, as you mentioned, there are huge variabilities in terms of network latencies, network availability. And so that brings in the question of being able to store messages locally and deliver them opportunistically as you have connectivity, which a lot of the data oriented systems typically don't factor in because they're assuming that everything is running on massive cloud hardware. You have high bandwidth network, you have reliable connectivity. If you do have a network outage, then it's a bigger outage than just one message. And so you have bigger problems to deal with. And I'm wondering how that also maybe changes some of the risks of managing messages and some of the ways that teams think about how to manage deliverability, where if they say, oh, I can throw it at my local NATS agent, it'll eventually make its way through the rest of the cluster. I don't have to deal a lot with error handling, retries, versus teams who are dealing with maybe a Kafka client and they say, I have to make sure that this message gets acted by the Kafka cluster when I generate it. Otherwise, I need to retry. Just some of how that changes also the velocity at which teams are able to move.
Yeah, and I mean, I think you bring a good point, and we used to call this tromboning, right? You always want to try to reduce tromboning. So even if you have a fast pipe and a decent RTT, let's say your RTT is 10 milliseconds to the cloud, right? And at least within NATS, when people look at Kafka and NATS, a lot of times people go, "Oh, Kafka can ingest messages faster than NATS," and it's because it's an apples to oranges comparison. In NATS today, every message you sent is acknowledged by the system. So it says every message is important. You know what I mean? What Kafka usually does is it immediately batches. And so it introduces latency to publish things as it's putting them together. And it has like I think a temporal window, and it figures out which, broker has, that partition XYZ. So we don't necessarily do that. But in general, what I think people look at is they don't want core data or services to have to be tromboned to the cloud in, let's say, a factory or distribution center where 15 minutes of downtime is extremely expensive, right? So even though they go, yeah, we pay for all this good networking equipment, unless something physically happens in the factory, that thing has to be able to operate no matter what else is going on, whether, I don't know, Azure or one of the other big hyperscalers has a blip or there's a network outage or something like that. And so the fact that everything within the NATS ecosystem can run on big hardware to small hardware, all the way down to ECUs running inside of a vehicle that are running both core messaging and Jetstream, with synchronous replication, consensus algorithms, everything, kind of coming and going. That seems to be very attractive to our customers. They like that. And so what they then eliminate the tromboning to is the NAT system that can self-heal itself. It puts itself all back together automatically. And so you can imagine a world where, the application knows it has to produce some piece of data. And let's say, it says that I'm supposed to persist this data. What we like pattern wise is don't ever assume who's going to use that data tomorrow, right? So if an application that's creating the data or publishing the data or whatever you want to call it, if you are looking at the code for that application and it is aware of who's receiving it, I think that's an anti-pattern. I think that's bad in modern distributed systems. And so what we allow applications running in a factory to do is say, I have to store this thing, and they literally just send a message just as if they were going to send a message for a microservices interaction, which is just NATS core, and they want to get a response back, and they get a response going, got it, and they're like, great, I can go and do my other stuff. But underneath the covers, that was stored locally, let's say in a closet, an IT closet, or on the shop floor. And then NATS takes over and says, oh, wait a minute, there's supposed to be a digital twin, a muxer, meaning it pulls from all of the factories or all the cars or whatever, and it puts itself together. It's, in other words, it self-heals itself. It makes sure there's no duplication. And so it will get it to there. And again, that's that. Don't assume who's going to use that message tomorrow, because there might be another process in the cloud that's running it. We might want to stick it in Kafka. We might want to run some of our own analytics, whatever that is. And so I think that those choices and those patterns lend well to edge-based distributed systems, which I think, in my opinion, the stepwise change from data center or server rooms, I'm dating myself, but I used to, in server rooms with a big Parker, hat on or whatever. When we think about how differently we architect in the cloud and cloud native or whatever like that is, I really do believe that the step change from cloud to edge will be even bigger. meaning all of the rules that you have in the back of your head around, oh, I can do this in the cloud. A lot of times they just simply don't apply, right? Because cloud providers, and this is not a bad thing, it's just not spoken a lot. They want to be Hotel California. They want you to check in, but they do not want you to check out, right? And so it's very hard for you to pick up not only your apps and your data, but all the stuff they provide that made it easy to get started. You have to figure out how to duplicate that at the edge, right? And so if you come into a small IT closet with a small little NUC running and go, yeah, we're going to set up Kubernetes and we're going to have Zookeeper and JVM containers and Kafka clusters, and they kind of look at you like, that's not how this edge at least works, right? Think about if you wanted to do that inside of a vehicle, and run these things on ECUs. It's just not going to happen. And so Synadia offers a solution there. But what we've seen with some of our customers that have been with us for 2-3 years now or so is that the pain point was an edge initiative, right? Something, right? But once they kind of get that working, they start to actually backport the architecture back into their cloud presence. And so they start removing things like SQS and, any type of thing that the cloud provider has built in that you can't just pick up and move when you want to move. And so we've seen that quite a bit with some of our longer
There
customers.
are a couple of interesting patterns that come to mind talking about the reliability, deliverability question, as well as some challenges from a system design perspective in terms of the NATS architecture. So, just briefly touching on that, what comes to mind is if you have clients that have unpredictable connectivity. They could be always available, or they could be heart beating once a day or longer. Is not knowing, not being able to predict whether that client is just having unpredictable network coverage or if it's just completely gone and dead, and you should never expect to hear anything back from it again, which makes it complex from a application and data perspective of I think I'm going to get data from this client or I'm just never going to get any more data. And then on the producer side, I'm thinking in terms of some of the patterns of like clickstream analytics where you might send them to a segment or a rudder stack, and I want to make sure that that message always gets through. I never want to drop any messages because this is core to my business observability, and I need to make sure that I know every event that every customer engages with. And so I can imagine that NATS is definitely a very useful utility in that regard, but also you still have the problem of, well, what if that server goes away and it had a batch of messages that it didn't get to send because of some network connectivity problem?
Yeah, I mean, and you raise great points there. And I think, modern distributed system architecture, we still draw the same boxes and squares and triangles on whiteboards, and Synadia and NATS don't want to change that, right? So you're still microservices and key value stores and object stores and relational stores, which we don't do, but we power a lot of the clustering technology for a lot of relational stores out there. But I think it's interesting when you think hard about, let's say, a microservice, right? And let's say we're talking about the responder, right? So I can get a request and I can send a response back. Earlier in the podcast, I talked about one of the core tenets of NATS Core was distributed queue groups, right? And so for us, just combining that and packaging up to what we call micro. So micro is just a mini framework inside of our clients, but they automatically do, distributed queue groups, meaning you can run these everywhere around the world. And what's nice is that the NATS system is updating itself all the time in real time. And so if I blip and I go offline and you send a message that's supposed to be for a Derek, but let's say there's 500 of us running around, if I go offline, the system knows that pretty much instantly. And so it won't deliver it. And if all of a sudden I reconnect and it's like, okay, you're back and you're available for new messages. Combine that with obviously Jetstream, which moves from at most once to at least once, and then exactly once. Exactly once is a tough one, right? I've been in those wars, so to speak, from very early on. For our perspective, it's kind of a bifurcated problem. There is the how do you do very efficient and semantically correct dedupe. In other words, I sent it, but I never got a pubback. And so it was a blip and now I'm reconnected and I send it again. I don't want it in the stream twice, right? And so that's one part of the problem. The second part of the problem is that you only receive or more technically process a message once on the consumption side. But in NATS, which is different than some of these other systems, is we went down the path that there could be multiple consumers for any given message. And so things like very simplistic, easy to rationalize DLQs don't exist out of the box in NATS because, believe it or not, it's an anti-pattern. In other words, if all of a sudden I think I'm the center of the universe and I couldn't process the message, so I want this message to go in a DLQ. In the NAT system, there could be lots of people that they had no problem processing the message. It's just me, right? But when you combine this notion of the NAT systems are updating, they always know when things are offline or online all the time in real time, or at least speed of light real time, combined with the ability to move from at most once to at least once and exactly once semantics, gives you at least a decent amount of patterns to figure out what you want to do. And so a lot of times, we get on calls with customers and or users who have been using NATS for a while, and we always try to start the conversation with, all right, you're going to tell us how you've deployed the NAT servers and what the apps are doing, but let's start with what problem are you trying to solve? You know what I mean? And what are the requirements of the system? And then the last question I always ask is, if everything goes perfectly right, how big will the traffic be in 2 years? Which nowadays, it used to be 5 years. Now it probably will be 6 months, the way the technology landscape's going so fast. But we try to cultivate all of those and both design the platform side in conjunction with the domain experts, the customer or the user, but also help them understand the what's versus the how. So the what's is microservices, key value accesses, things like that. The how is where NATS changes the game, but it's not changing the what. It's just changing the how. And so in very sophisticated, very, very high level critical deployments, we spend a lot of time with the users and the customers around how we're actually doing the things under the covers and what to look for, when things kind of go wrong. One of the things that NATS did that was by design, but I kind of regret, was we try to make it so easy to spin one of these servers up to create a cluster or whatever, that we have a lot of folks that come to us and go, yeah, we're having issues. It's been running fine for 6 months, but they never change it. They set it up, they never change it. The app tier's changing and growing and expanding. And they're like, it's kind of like taking a pickup truck and loading it with 2 tons of stuff and going, why are my tires flat? And so that's kind of bit us a little bit with people going, this is still a very complex distributed system where you might be running in multiple regions, cloud providers out to edge locations with, again, in most one semantics, at least one semantics, mirroring digital twins, all this stuff. But we love working with super hard problems with these customers. So it's a good thing, but it is funny to see. It repeats itself quite a bit.
Another element of the overall problem is the guarantees that end users should expect, where again with distributed data problems, there's the cap theorem, it's unavoidable. And so you can either say you have serializable consistency, it's always read after write no matter where you're writing to or reading from, or there's eventual consistency, and so you can read your own writes as long as you're talking to the same node. And then there's also the challenge of, as you were alluding to at the beginning, horizontal scalability, where you want to be elastic. You don't want to say, I start small and then, I need to be able to get bigger, so I go the next size bigger, but now I can never collapse back down because then I start losing data, I start losing messages. And so just some of the ways that the architecture of NATS addresses some of those problems of horizontal scalability and elasticity of load, as well as some of the guarantees that it offers beyond just the message semantics.
Yeah, I mean, for core NATs, right, you could probably scale up and down, but we usually don't recommend people to do that because most NAT systems these days are running Jetstream. And so we have one customer that just yesterday was asking, hey, our system got into a kind of a funky state. And what they were trying to do was they were trying to scale it up. And so the way we designed the Jetstream layer, it has, when it's in clustered mode, it has the notion of what's called a meta layer, which is a membership layer, right? And it also does all the CRUD operations for streams and consumers and things like that. But it can add things. So if it sees something new, it goes, oh, okay, well, I guess Tobias is a new member of our group. Great. You welcome him because we saw you. We saw you. You're connected to us, meaning you had the credentials to get connected. We saw you heartbeat. We know who you are, XYZ. However, the inverse is not true. If you all of a sudden go away, meaning I can't see you anymore, I can't assume that that means you're gone, and remove you. Right. And so I think what this customer did was they then shrank the system down and it just locked up. And the reason it locked up is like, I can't make any progress because I can't make a quorum. We used to have 6 and now we only have 3. We need 4. And it's very counterintuitive when we say, hey, start one more server and you'll be fine. They're like, what? But they go, well, why wouldn't you just auto remove it? So we walk them through, okay, let's say one of your things goes offline. When should we remove it? After 30 seconds? After 2 minutes? after an hour, and I tell them, hey, every customer will tell us a different number. So the answer is we can't, but we have architecture systems that can shrink down because we have the mechanism to say, no, Tobias is leaving, remove him from the set, right? There are operations that can do that. But if someone who looks at Kubernetes and looks at NATS and just goes, oh, I just want to scale from a 3 node cluster to a 6 node and back down to a 3 node, NATS kind of, you can do it, but you need to know all the moving pieces. You can't just hit an easy button on both sides and say, yeah, that should work fine. And we do, to your point of reads after writes and things like that, we do quorum-based semantics right now. So we can do stale reads if we're in what's called direct get, high speed direct gets use DQ. So that same thing from NATS core, and hopefully the audience is discovering a pattern that our data layer, in our opinion, is special because it is based on the core layer. It's taking advantage of all the stuff, location independence, the DQ, all that kind of stuff. But in that instance, right, if all of a sudden you have 5 members, you only need 3 to acknowledge the message, and we can get back to the publisher and say you're good. And then they could issue a direct get read saying, I want to see that sequence number. And it could go to one of the replicas that's online, but it just hasn't processed it yet. Now, obviously, you can say, no, I only want to talk to the leader. But a lot of times people are, and this is not new, but people are always in conflict of speed versus, consistency or correctness. Although, every time I see someone write a message and then try to read it right back, I go, you have the message in your hand. Why are you doing that? But they go, I need to read back exactly what I write. And so we can set those up. And then they go, hey, why did the performance just drop? It's like, well, all your reads now have to go to, the leaders. And so we're working with customers around some of those issues. Nothing has been fatal, but we have been called out a couple times now, being totally transparent of saying, hey, I tried to read what I just wrote and it was different. And I have a 5 or 7 node cluster and, the replication factor is, let's say, 7. And so we're looking at that. We also get a lot of people going, I just want to throw data at you as fast as I can and have you store as fast as you possibly can, meaning they want kind of the Kafka ingest, meaning I don't care if it's takes a long time to get an act back. I want to be able to batch. I want you to be doing all kinds of tricks. And if something really bad happens, I'll lose data. And it reminds me of a story at Google where I didn't work in the ads group, but I looked at some of the ad stuff for a while on the behalf of my boss at the time. And I said, hey, if X, Y, and Z happens, you guys are going to lose everything. And he goes, how much would we lose? And so I said, well, I think you'll lose, at least an hour, maybe 2 hours worth of stuff. And he goes, do you know what we would lose if we didn't go at that speed? And the number was astronomical, meaning, you know what I mean? They chose speed over if something really bad happens, they might lose some of the CPCs and all that other stuff. And so it's always a trade-off. And that's, again, why if I'm on a call for the first time with a customer, I always go, I get it. You guys have done a lot of stuff, but let's back up. What's the system supposed to be doing? And what do you care the most about? What's the most important? And it usually makes folks think slightly differently, and then I'm not saying they're minutia, issues down below, but they think very differently of, oh yeah, I was trying to get it to do this and I just should be doing it a totally different way, which I think is healthy, right? It's good. And all of our best results, by the way, come from the Synadia team and our expertise at but not only NATS but distributed systems with the domain experts, right? That those are always the best solutions.
Digging a bit more into the ecosystem around NATS, obviously it's very straightforward to get started with. It's very flexible. There are a lot of layers of software that have been built up over the decades. And so if somebody has a solution that is mostly working and they say, actually, I need what NATS is giving, but I don't want to have to rewrite this portion of my stack. I just want to be able to plug it in and start using it right away. So I already have Kafka, but I just want to use NATS because it gives me better flexibility, or I'm already, using something like a log Taylor, but I actually just want to send my messages directly to NATS instead of worrying about writing to disk and then having it get read back. And just wondering, what are some of the characteristics of the ecosystem around NATS to be able to provide that flexibility of adoption without having to do a huge investment specific to NATS versus some other generalized pattern?
Yeah, I mean, that's an excellent question. And I think, internally we call that moving from greenfield to brownfield. And so what I mean by that to the folks listening is greenfield is the pain you're experiencing is so high that you'll rewrite everything to fix it, right? You know what I mean? It's like you'll take a clean sheet of paper. And again, we don't change the what. So all the boxes and squares and triangles all look the same, but the how is very different. And Synadia and the NATS ecosystem in general are definitely in a transition from greenfield to brownfield. And so there's three things that are going on there. So right off the get-go, and this has been around for a while, we built a bidirectional Kafka NATS bridge, right? That now has turned in an ecosystem of, I think we're up to 100 different connectors, which we're about to release to connect bidirectionally to pretty much anything. S3, Kinesis, SQS, Mongo, Splunk, we got all these types of things. So that's kind of one area of concentration there. The other big one is that, and we told this to investors early on, one, we're going to be misunderstood for a while, and you have to be patient with that. And two, if we're ultimately successful, most people won't interact directly with the NATS technology itself, meaning we will brownfield the last mile. And so about 3 years ago, my numbers might be off here, Tobias, but I think about 3 years ago or so, we introduced native MQTT support into the server. So you can just take an MQTT client, just point it right at a NATS system, and it works. And so that's that last mile for the factories. And I think there's a renaissance going on in manufacturing right now, where it's combining the high level information flows with the low level data coming off of all the machines, the sensors, things like that, which a lot of them, not all of them, but a lot of them are MQTT enabled. And then, of course, the other big one, which this might surprise folks who know of NATS or know of my opinions, I don't think NATS everywhere makes sense. Last mile is HTTP, which we have for Synadia customers. We have an bidirectional HTTP gateway. So you can literally curl commands to put stuff in streams, take things out, interact with KVs, XYZ. I think all of those are good. Where I struggle or get confused, I guess, at what people are really trying to do is when they go, no, we'll do HTTP for everything. And again, I'm not necessarily against HTTP. I just use the right tool for the job. And I was at a conference a few months back, and someone said, "Can you give me a good example of that?" And I said, think if AT&T used wireless technology for everything, not just to last mile connect to your phone. Or think about if NVIDIA's GPU cluster just used 10 base T networking, you know what I mean, which is the equivalent of like an HTTP type thing. And it kind of starts to resonate, and people go, "Oh, I get what you mean." So I think there's a place for something like NATS that is, at its core, location independent. It's end to end, not one to one, and it's not request reply. It's multiple paradigms, meaning push and pull. Then combined with that, the data layer on top of it, that can be very, very powerful. But at the same time, if you want to just use fetch from a browser to get something, you should be able to kind of do that. Now, we do have JavaScript clients that run in the browser, and so we do have customers that take NATS all the way into the browser, right? And are even synchronizing databases through CDC feeds right over, into the browsers type stuff. But we also have people that say, no, we want the browser to do a customized HTTP API to the backend, and then it flips over to NATS back there. And both of those are correct depending on what you're trying to do. And so things like WebSockets and MQTT and HTTP as these last mile extensions make a lot of sense. Now, where we start to not butt heads, but kind of have philosophical differences is that when people go, hey, we expect everything to be architected on HTTP, and then we build our complete security story around that. Everything has to go through a WAF or something like that. That's where we kind of scratch our heads and go, that doesn't feel right to us, right? And I even believe one of the big paradigm shifts going from cloud out to edge, the far edge is that I don't believe that world perimeter security models will function the same way or at the same level of intensity they do in the cloud. And again, for the audience, it's kind of like NATS is more like your iPhone or your Android phone. If you paid your bill and you have your SIM card in, you are a production user. Doesn't matter if you're at your house, at work, on a plane, traveling, it just works. And NATS is kind of like that. Now, we work with perimeter security models, right? We can definitely, mix and match, but we believe that the weight that people put on perimeter security models today is too much, at least in our, and the same thing with everything has to be HTTP. That way we know our security story, which is a WAF man in the middle, essentially approach. We just feel that might be a little short-sighted.
Your mention of interacting with NATS via the HTTP bridge and being able to effectively treat it as a backend or a portion of your backend system also put me in mind of some of the patterns that have been growing up in some of these streaming systems of having sort of an embedded functions as a service use case. So I'm thinking in terms of Red Panda and being able to use their WebAssembly binaries that you can plug in to say perform this operation on every message that hits this stream, or the pulsar functions capabilities, or also just generally the
Yep.
lambda or openfaz. And I'm wondering how you think about that in the context of nats and effectively decomposing your application backend as well to just a series of operations on messages that just get mutated and put back into the same or a different queue.
Yeah, I mean, and that's one, we recognize the importance of that. And I even was like, when WebAssembly started coming into, vogue, I was like, let's maybe consider this. But the reason that we haven't done that yet is one, being able to debug something like that, let's say us trying to debug something running in a factory or an air gap facility or something like that. I think a lot of people at Synadia might quit, right, if we did that. But the other one that might not be as obvious to the audiences is that if the central nervous system, and again, most of our customers will say we're their central nervous system, the central nervous system's components that are moving things around and storing things are going to be very small compared to the number of things interacting with it. To give you an example, one customer has, I think, 6 servers, and they're supporting 100,000 connections of this fleet, right? And so where we've come down on is a bunch of our enterprise customers were really asking us to think harder about auth Z and auth N. We have our own root of trust, we have our own things, but we can interop with MTLS and things like that. But they're like, no, we need to be more opinionated on auth Z or more opinionated on auth N. And so what we designed was a system, this was about 2 years ago, called auth callout, which you tell the system, hey, I'm instructing you to not do auth Z and auth N, and I want you to send a message on this subject in this account, and what you're going to get back has to be digitally signed. It's encrypted, so it's a zero trust construct. So there's a lot of complexity, unfortunately, to get that level. But essentially, whatever I come back with, that's what your auth and auth N constructs are. So what we've designed, but we haven't started implementing it yet, but it might come in 2.12, is this notion of generic callouts, which is any message inbound on a subject can be dictated to say you have to call out to this protected subject that no one can access. You can listen for it, but you can't ever publish messages on it. And then you return a indicator of what you want us to do. So you might be able to return just a little check mark on, yeah, it's fine, just send it. Or you might say, no, replace it with this. I rewrote a whole bunch of fields and, I knew what it was. Because NATS, for the most part, at its core level is payload agnostic. It doesn't understand what the payload is. But of course, systems and applications do. But what's nice about that is that these callouts, generic callouts, use the micro framework that I talked about. You can run thousands of these for a single server. It can be pumping messages out. And that server, I haven't done the math lately, but the last numbers I remember is core raw routing processing speed is about 20 million messages a second. But let's say your auth N and auth Z takes 5 milliseconds for each one, right? Even if I had that WASM module inside of the server, right, it's only one server, right? And so it's running, I think WASM is single threaded still, right? They're still working on the multi-threaded and networks and all that other stuff. So we think these zero trust generic callouts is probably going to be the answer. And then Synadia can package up prepackaged things, right? And say, hey, you're good to go there. And so that's kind of the way we're probably going to be dealing with that. So I guess that's our version of Lambda. But embedding stuff into the server, it sounds like a great idea. Even I was considering it, even though I got burned in the 90s around some of these issues. But when you really step back and look at mission critical production systems, they have to be deterministic. You have to be able to triage and debug them in the production setting, and they also have to scale, right? And so we would hate to see, a NATS cluster that's 500 servers just because that's how many they needed just to process, let's say, some schema check, right, for requests or responses or something like that. So I believe, the team has settled largely on generic callouts being the mechanism for things like schema in validation, both advisory mode, but more importantly, enforcement mode. One of the Synadia folks, actually our chief architect, Ari, he's a big fan of things like OPA, but he also believes OPA shouldn't believe inside of the NAT server, but we should have a very clear interrupt with it. And callouts could allow that, right? So you could call out, I have a request to create a stream. I hand that thing to OPA with, the auth N and auth Z, which is you, Tobias. Let's say you're making the request, and OPA says, "Yep, he's good to go." But if I sent it, OPA comes back and says, "No, Derek can't create a stream in production to do whatever he wants." So that's probably the approach that we're going to roll out. Hopefully, fingers crossed with 2.12, which is I think sometime around the September timeframe.
In your experience and history of building nats, growing it, using it both in terms of solving your own problems, but now growing it into a service and building a business around it and working with your clients. What are some of the most interesting or innovative or unexpected ways that you've seen the technology applied?
That's a good question. We have a bunch of diverse use cases. Most of the folks that started the company, had some affiliation with TIPCO, or Apsera, the startup I did before Synadia. And TIPCO's products obviously were very big in the financial markets, and we do have a lot of financial customers for sure. But what took us by surprise was the adoption around manufacturing, the connected car. So we do a lot of work around connected cars where again, we try to eliminate the tromboning. And so you can imagine a world where the communication patterns are NATs in the factory, inside of the cloud, and inside of the vehicle, whether you're talking to the cloud or not. So if you're just talking to a service that's running in the vehicle, that's still all over NATs. And then the last one, which we kind of knew or we thought that we could play an interesting role here, was on the AI inference stack at the edge. Again, so you can imagine the problems that are happening there, which is I need access to data to augment my prompt. Right now I access a model, but I might not know where it is. And now, of course, we're quickly going into a world where we're accessing multiple models, which we might not know where they are, but we need to trust them. And conversely, those might be walking through multiple agent, tooling and things like that. And so we've been doing quite a bit of work with some of the very large players in the space around inference as a service and having Synadia and NATS kind of power that functionality, not only from prompt augmentation, flipping RAG from a pull model to a push model, where you don't have to scale every single RAG component with your inference layer, to multiple traversals of models or agents, as well as data collection. And so that was kind of surprising. But we see, somebody I think has it running inside of a toothbrush. Someone put it into Home Assistant, so they use Home Assistant, but powered all by NATS and MQTT to control everything in their house. We've done a Tailscale clone internally just because we could. You know what I mean? Where everything goes over NATS, but it just looks like a ton tap, interface, and it's just everything is just TCP as that last mile, pure TCP, but it's routing and stuff like that. And the cool thing about NATS is that we could actually do like broadcast and multicast if we wanted to, because that's just naturally, pub sub type of stuff. We've had people plug it into Olama so that they could send NATS messages and get Olama responses from a farm of Olama instances running different models, things like that. We have a lot of database customers that use us to do their clustering tech. We have customers that use us to do CDC and filter down database from, let's say, Postgres or Cockroach to, let's say, SQLite in a browser type stuff. Those were kind of interesting for
Very
sure.
cool. And in your experience of building this technology, building a business around it, investing in the ecosystem, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
Ooh, that's a good one. One we already alluded to, which is the decision to make it very approachable and easy to start with, kind of seems to be biting us now as people are trying to do very complex things and they don't realize that, complex distributed systems need a lot of expertise to understand how to set up right and to monitor correctly. We have customers who will come to us and say, hey, we had an issue. The system's fine now, but something happened last night. And we'll look at their system. We're like, your system is not fine. It's been screaming because that's just not quiet. It screams. But if you're not listening for all of the advisories flying around going, hey, I don't like something, you won't see it. So that was very surprising. The other one, to be honest with you, that again could be a podcast on its own, is this notion that you can start a company based on support models around open source, right? But I don't think you can necessarily grow a business around that. But to start one, I made the assumption, which I was convinced would be true, is if we are mission critical, which I would say 99% of our customers are all mission critical, meaning if we go down, my phone will go off, right? So I put on do not disturb and everything, but my phone will still buzz if there's a production outage with either our global cloud service or any of our customers. I understood that part. What I didn't understand, and that they would want a commercial agreement, right? The one neck to choke or whatever you want to call it. What I found, though, that has really been occupying a lot of my mental energy over the last 18 months or so is that I see a very interesting trend, which is if our incentives are to make the software as good as possible, the least amount of bugs as possible, the docs as best as possible, reference architectures as best as possible, then our potential customer set is disincentivized to actually pay us, right? And so we have a managed platform, right? And we'll manage it for you. And your psychology is, oh, I'm paying them to every day look at our system and make sure it's up to date. And if there's any security things or if there's trends that they're watching and seeing, they can tell us, hey, you're going to run out of blank resource, network, disk, whatever, and we'll handle it type stuff. That psychology is very different than the psychology of I paid this amount of money and I filed one support ticket. I'm wasting my money. It's almost a soapbox that I get on, but I don't do very well on. But it's kind of like comparing Eastern and Western medicine. Western medicine, you pay the doctor when you're sick. Eastern medicine, you pay them when you're well. When you're sick, they're not doing their job, right? And so, any type of OSS ecosystem where there's a single company that's driving it and they want to make a business out of said technology, not ancillary stuff like Basecamp, right? They put a lot of effort and DHH into Rails, but he made a very conscious decision that that's always free and that they're going to build stuff on top that'll never be free. You always have to pay for it. But for any company like Synadia that started saying, hey, we're pushing really hard, and I think we tallied up, I think investment wise in that, it's been, I don't know, 25, 30, $40 million to date. You know what I mean? That incentive misalignment concerns me, where people go, and I've even heard rumblings of, oh, well, if you're in a foundation and the project graduates, then perfect. That's when we can stop paying you. And this isn't Bob and Vinny's pizza shop out of Venice, California. This is Fortune 500 companies that you would know the names if I mentioned them that say, yeah, we're not going to pay you, type stuff. And I don't think enough people are looking at that problem. Now, the reason they might not be is that things like Kubernetes, where all the hyperscalers have, a hand in the pie and they all make money off of other things besides that, right? They can do that. But I think a lot of the really revolutionary things are companies creating an idea. They want to make it open source because they want to have that community engagement. But they're a business, and when they start out they're getting VC funding, but they have to flip that over where they can self-sustain themselves. And when the consumer bias is this should be free or I'm not going to pay you once you get all the bugs worked out type stuff, that was kind of a big eye-opener for me. I was like, ooh, this doesn't feel like we're heading in the right direction. And last word, and then I'll stop on that because you can tell I can go on for a while on this subject, is charity is not a business model, right? And so if you're sitting there with a donate page on your thing and you're like, that's how I'm making all my money. Um, if you're an individual, or one or two people and stuff like that, that kind of works, but I still feel pretty convinced that charity is not a business model. And so that and the OSS incentive misalignment, those were the biggest surprises that I've seen. As Nat says, I don't know how many downloads we're at to now. It's some big number, and 400 million, I don't know, somewhere like that. That was the biggest surprise. The other one is that's not as important as that, but it was interesting to me was when I designed Jetstream originally, I was like, yeah, if someone goes crazy, they might have 100 consumers that are looking at data in the stream. And that proved to be very untrue. And so we have people that say, no, we want to have hundreds of thousands of observers to the stream, or even millions of observers. And if you look at the way TIBCO's EMS did it, which I architected, or even the early versions of Jetstream, consumers are heavyweight, right? They're doing a lot of things. They've got their own consensus algorithms. They're, tracking a lot of state unless they're just a simple fire and forget. And so we had to adapt very quickly at some of these early Fortune 500 customers that said, well, what if I want 40,000 consumers on the stream? Or what if I want, a million observables on a KV key? How does that work? And what they did was they immediately just reached for a NATS consumer, a Jetstream consumer, which again are very heavyweight in the system, hey, I have a 3 node and it's running in Kubernetes and I gave it half a CPU and 2 gig of RAM. Why is it falling over type stuff? And so that was a little not surprising that they tried it that way. That made sense to us. But the fact that they were expecting, oh yeah, we can just throw hundreds of thousands of consumers at a stream, and it should just work. And so we've worked really hard at delivering different constructs within the system to do those extremely high numbers. But right now, they feel a lot of one-offs and interactions with our customers. And so the team has slowly seen the patterns that are resonating with everybody. And we're starting to kind of collate those up into some concrete ideas that we can put into either directly into the clients or what we call Orbit, which is kind of our experimental client editions, where they can say, I want a consumer, but I want a super lightweight consumer. You know what I mean? And it's like, oh, yeah, we can run millions of those. Whereas I want a full-blown, durable, redeliveries, individual acts, all this stuff, consumer with dedupes and all this, crazy stuff going. and they go, I want, 100,000 of those. And it's like, yeah, you can do it. You're just going to have to throw a lot of hardware at it, right? There's a lot of machinery to do that. So that surprised me as well. But I guess I should have seen that one coming. And then, of course, we already mentioned the KV, where I was like, nobody is going to use KV for anything crazy like to replace Redis. And I think we released an alpha version with a short video. And by the next day, someone was saying, hey, I've got 2.8 million keys in this thing and it's starting to slow down. And we were like, whoops, okay, we misread that. And so now we support, hundreds of millions of keys and, with big customers and stuff. But that surprised us as well.
And for people who have been listening, they said, great, NATS is going to solve all my problems. I can just throw away all my other tech. What are the cases where NATS is the wrong choice and they should stick with some other pattern or technology stack?
I think when you're doing super high ingest rates, when you're taking advantage of like Kafka batching and the partitioning schemes that they do, again, when we actually artificially did the batching on our own, just as a hey, because we think we're pretty fast at a lot of stuff, but we process every single individual message. But once we batch messages and made it more of an apples to apples, I think we were actually 2x faster than Kafka, I believe. And so we're going to go ahead and do that. But right now, that doesn't make sense. If you have massive investments, you've got a team of 20 people running a Kafka cluster. Yeah, it might look nice to, repurpose all those people and do something cheaper, but all of the processes and all the operational stuff around it might not make sense. If you're talking about petabytes or exabytes of data, you know what I mean, and hundreds of servers and stuff like that with a team of 20, people with a Kafka cluster, we're probably not yet the best for that, although we do have visions of getting there. But right now, we would tell you not to do that. So those are probably the two big ones that I can think of off the top of my head. So super fast ingest. Again, it's not apples to apples comparison, so we understand why it looks different, but we're going to solve that one. And then for KV, if your value proposition is not in clustering or stable storage, that's not your pain point. It's you're really taking advantage of the value semantics. Today, we would say don't replace Redis with us because right now we look more like Memcache than Redis. But for those that do care really about clustering agility and the ability to dynamically create topologies in very random fashions and stable storage, then we do have a bunch of customers that have moved to NATS for that because that was their pain point, and they're working around hopefully a short term while we don't necessarily do value semantics like Redis does.
And as you continue to build and iterate on NATS, you've mentioned a lot of the things that you have that are forward looking and changes that you have planned. Are there any other aspects of the future trajectory of NATS or the work that you're doing at Synadia that you want to share with the listeners?
Yeah, I mean it's an awesome time to check it out, especially as Edge is becoming so dominant. And if you're in, AI inference at the edge types of problems, or in manufacturing types of problems, or distribution centers, or even connected car or connected fleet of any kind, those we have a lot of customers in those spaces, and we've not only I think delivered really cool tech to those ecosystems, we've learned along with those ecosystems of the things that we needed to do differently or change around. And so I think that's great. And going forward, right, we're going to do the key value semantics. So counters and lists and maps and things like that. Lots of massive scale. Right now, if you do event sourcing, and every single message has a different subject, they're all unique. We keep that meta information in memory, right? And so once you get to about 40 million, you're using up about 20 gig of just meta information to just hold us so that when you ask for a subject, which is a key, we know which block to pull up and XYZ. And so, but we have plans on really making that massively scalable. And we, again, to make it apples to apples, we have notions of loosening consistency algorithms and quorum algorithms internally. When we originally designed the system, we could do about 1 million disk writes per second in a cluster. But we had a customer that said, hey, well, what happens if every disk runs out of space at the same time? You have multiple ones have them in memory, but they can't write it anywhere. And so at the time, we didn't have time to do the trick that I did with TIBCO's EMS. And so we said, okay, we'll turn that part off. And so we punched through to the kernel and the disk subsystem every time. And so that brought us down to about 250,000 per second, that we can write. And so we're going to offer in an opt-in version saying, I'm okay if it's a little bit less consistent, but you need to be able to ingest 1 million messages a second in a single stream versus partitioning it out, kind of like the Kafka world, right? Where you've got sometimes they've got so many partitions, and then someone says, "Hey, we need to add another one," and then apparently that's not a fun day in Kafka land. Apparently, when you have to repartition
Are
everything.
there any other aspects of the work that you're doing at NATS, the patterns that it enables, the adoption or implementation that we didn't discuss yet that you'd like to cover before we close out the show?
No, I think, for closing thoughts for the audience and the listeners is Synadia's approach with taking NATS as a technology, a foundational technology, is to modernize how distributed systems are built that can cross regions, cloud providers, and most importantly, out to edge. And that the what doesn't change. You're still designing microservices and key value stores and object stores. And again, we don't build relational stores, but they're always a component, right, in these whiteboard sessions. But how that changes is a big deal. And then the last one is that we are making the transition, the greenfield, the brownfield. We've already done the MQTT and HTTP, but you'll see us in the next couple of weeks or so release our connectors technology, which allows you to connect pretty much anything right out there. So we think that that's going to be a really big deal for a lot of our users and ecosystem.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think data management, in my opinion, so there's going to be a lot of people that probably don't agree with this, but it aligns with what Synadia tries to do, which is we need a way to be able to, in real time, decrease latency to access a service or data. So let's take data, for example, in that case. Where things start to break down isn't necessarily, I mean, NATS does this very easily. We just kind of get a lot of this stuff for free. But where it becomes really important is that regardless of where things are deployed, that you have a consistent and dependable security story. That if that piece of data lives in the cloud and Tobias, our host can access it, but Derek can't, that rule better be the exact same if the data gets duplicated into a factory. And all of a sudden I show up at the factory and I log in as Derek and I go, "Ooh, can I read this message?" It should say, "No, you can't." And so when you look at the security around data access, and then you look at how things within cloud native, mostly being reliant on perimeter-based security models, that's probably the biggest mind shift. The second biggest mind shift that I've seen is security groups within companies that just say everything has to be HTTP because all of our tooling is just HTTP. That's all we know how to control. And I don't believe HTTP is bad, but I believe it's bad if you use it for everything. And again, it's like, NVIDIA using HTTP to connect their GPUs, in a supercluster. No one would think that's a good idea. Yet software people design these big distributed systems, and all they're using is HTTP or an HTTP derivative like gRPC, right? Which is still, I have to know where you are. You know what I mean? And if you can move around, we have to do unnatural acts to make that happen with load balancers and DNS tricks and things like that. And so, security movement with consistent security across different deployment paradigms. And I'm not talking Kubernetes versus systemd versus just Docker. I'm talking about cloud, different regions, different cloud providers, different edge locations, all the way down to very, very small resource limited environments like ECUs inside of vehicles type stuff. And then HTTP being the end all be all of communications I don't agree with it, but I'm also going to say if you're building a really small app that gets, 5 or 6, requests a second, okay, fine. Where I get concerned is that the perimeter security model folks are also moving to everything has to be HTTP, and we have a playbook for how do we think we secure that internally. And I don't think that that's a good thing, or it needs to be looked at again. How about that?
All right. Well, thank you very much for taking the time today to join me and talk about the work that you've been doing on NATS and all of the capabilities that it enables. I could definitely talk to you about it all day. So I appreciate you taking the time and all the work that you and your team are putting into bringing this capability into the world. So thank you again, and I hope you have a good rest of your day.
Thanks, Tobias. Thanks for having me on. I appreciate it.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.